Okay, so we've looked at the sampling distribution of one population proportion, what happens when you look at all the possible proportions you could get and how are they distributed. Now we're going to do the same thing for the sampling distribution of the mean. So first let's start with a question. If the mean salary at a company is $56,000 and the standard deviation is 10,000, how likely is it that the average salary of a random sample of 100 employees is less than $54,000? To help us see what's going on, we're going to do a little experiment. Suppose you roll a die 500 times and you make a histogram of the results. So a histogram of the 1s, 2s, and 3s you could get. So it looks something like this. Or does it look something like this? Does it look like this one? Again, this one, where it's sort of flat across, numbers between 0 and 20. Looks like maybe this says we got about 34 number 9s and about 14 number 4s. Or does it look like this? More like a normal distribution. Or does it look like this, where it's sort of flat across, but all the numbers are between about 6 and 12. So you roll a die 500 times, make a histogram of what you get, the numbers you get. Does it look like red, green, or blue? So hopefully you said blue. The results you get really are distributed between 1 and 20 and roughly equal numbers of each. This was a simulation. This was an actual simulation, and of course they're not going to be exactly the equal number of each. But there's no reason to think that the results you get should be concentrated around 10 or 11 like this, and notice that it doesn't go above 14. And there's no reason to think that somehow it doesn't get above 12, that you never roll a 13 or a 14 on a 20-sided die, or you never roll below 7. So this one is right. If you roll a die 500 times and make a histogram. Now, though, what if you do something else? We're going to change the experiment. We have 500 students, so we're still going to get 500 data points. But this time, they roll the die, each rolls the die 20 times, and they average the results. So each student rolls the die 20 times, takes the average, and that's what we report, and we record those 500 numbers in a histogram. Does it look like blue, green, or red? Blue, green, or red? Well, this time it turns out it looks green. And this ought to make sense. If you roll the die 20 times and average the results, most of the time when you roll it 20 times, you're going to have a mix of high numbers and low numbers, and so they should average it out around the middle, 10s and 11s, and that's what we see here. Only a small percentage of the time, if you roll it 20 times and average the results, where you get a number as small as 6 or 7. Relatively unlikely. And oh yeah, it kind of follows a normal distribution, and that's exactly what's going on. So this is called the sampling distribution of the sample mean, the collection of all the sample means you can get when you do the experiment, when you take n points from a data set and average them. So all the sample means when you look at samples of size n and average the results. So if the original population has mean mu and standard deviation sigma, then the collection of all possible sample means approximately follows a normal distribution, has mean mu, and then here's the bonus, has standard deviation sigma divided by the square root of n. So while the data itself might be quite spread out, if you look at sample means, they're going to be less spread out because you're dividing by the square root of the sample size. So now we can answer our original research question. If the mean salary at a company is $56,000 and the standard deviation is $10,000, what is the probability that the average salary of a random sample of 100 employees is less than $54,000? Well, the salary data itself will be highly skewed. Salary data always is. But the sample means, when you look at samples of size 100, will be pretty close to normal. If the sample size is very small and the data is really skewed, it might not be that normal. But by the time you get to sample size of 100, even if the original data was skewed, you'll get something quite close to a normal distribution. And this normal distribution will have mean $56,000. That ought to make sense. If different people take different sample means, if the actual population mean is 56,000, then you would expect the sample means to be centered around 56,000 too. And the standard deviation will be 10,000 divided by the square root of 100, or 1,000. So now we can answer our question. To find the probability that the sample mean is less than $54,000, we're going to find its z-score. Well, there it is. 54,000 minus 56,000 over 1,000 is negative 2. Norm S dist of negative 2 is 0.023. And so our answer is 2.3%. So with a large standard deviation like $10,000, one salary below $54,000 wouldn't be surprising. But at the average of 100 employees being below $54,000, that would be quite surprising. It would only happen 2.3% of the time. So this was a pretty much light speed introduction to sampling distributions of the mean, but go back and look at it and make sure you sort of understand the process by which we solve this problem.